Hello, everyone. This is session 2.3. Welcome. And there is only one rule I would like to remind you that you are kindly requested to present your studies within 10 minutes. So, based on the list I have, we can start the session. In the first place, paper ID 29, Omar Hisham. Are you here?
Yes, I'm here.
Okay, you can share your
Can you hear
screen.
me? Is my voice and everything clear, first of all?
Yeah, everything is okay.
Right, perfect. Okay, so hello everyone. My name is Omar Zagdoul, and I'm from Kadir Has University, Turkey, and I will present a paper about real-time pose recognition using smartphone-friendly computer vision. So, first of all, let's start by defining our problem. That is, having the home fitness training is popular. However, it is facing an issue due to the unsupervised practice that can lead to dangerous consequences, as it is reported to be causing 27% annual increases in injuries due to the unsupervised training. Additionally, users are not happy with the current applications that are helping them with their home exercising, as it shows as it is reported of 43% of dissatisfaction in the current applications. And our major gap in this issue is that we want to achieve a high accuracy model uh, that can be as efficient in the smartphones, because having a high accuracy model is usually slow in terms of performance due to multiple computations. And as our target, we want to implement a system that have this balance between a speed and accuracy in the real-time recognition using a smartphone-friendly model. Therefore, our approach is to build a hybrid model using these main parameters. And as our features in this model, we are going to rely on two different features. First of all, we have the pose feature, which is going to be by using MediaPipe to extract 33 skeletal body landmarks that will help us to define the pose patterns and therefore will help us to classify based on the pose. Additionally, we will need the um, image features, as we will use a lightweight neural network, which is in our case is MobileNet v3, and it will be used to analyze the visual aspects of our image. Now, moving forward to our system structure, and we are going to merge between the we are going to take the pose features, the image features, and then we will fuse them in our classifier. And for our classifier, it is trained based on a set of uh, 1,200 images of static poses that are mostly used in workouts and also can be used in yoga exercises. And one of the most common examples of static pose is the plank exercise or the tree position exercise, and etc. And we will go through that in the following slides. And for our training process, we reused two different methods. We used five-fold cross-validation, which is done to prove that the model performance is stable and not just memorizing the dataset. Additionally to that, we use data augmentation to simulate real-world scenarios by applying random rotations, random zooms, random shifting in the images, which will help the model to increase its efficiency. Yeah. Now, moving forward to our results the of the model in comparison to the other common model that which is ResNet 50. So our model successfully achieved overall of 87% accuracy on our test set, and we tested our model against ResNet 50 model. And as can we see in the tables in here, our model shows consistency and accuracy, and it shows a higher overall score such as F1 scores and the precision scores in comparison to its corresponding ones on the ResNet 50 dataset results, which can be also noticed as we can see in the following confusion matrices. As on the left here shows that diagonal shows a stability and robustness in the training process by having the diagonal line of meaning that indicate as an indicator of correctness and efficiency of our model. While on the other side, for the ResNet 50 model results, it shows a little bit of confusion in multiple data and instability in some results. As we can also not rely on some numbers we have to test in real life scenarios. So we tested the model in multiple cases using a uh, multiple devices, using a camera device to capture the multiple poses and indicating how close it is to the actual pose. So we tested in here, it shows that it could classify multiple poses. In our case, we have the plank, bridge, and mountain poses, and it shows a successful classification in each of the cases with an overall confidence rate that exceeds the 90%. Concluding the results that are obtained, we were successfully able to implement a hybrid system that can balance between high accuracy and that is between 87 to 97% and maintaining the high efficiency which is necessary in the real-time recognition and maintaining its stability to be used for smartphones and being able to be handled by the limitation of the smartphone hardware. As our future work, we are planning to expand the dataset to handle more poses and having multiple conditions while having as we are going to have in dataset such as having bad lighting, different rotations, different zoomings, etc. Moreover, we are also wanting to expand the classification process to be able to evaluate the quality of the position and not just saying what position is it and how correct is it, but also give a good feedback to correct the pose and therefore ensure more stability and therefore less injury rate in the future work. And that's all for this uh, presentation. And thank you so much. And I will be accepting questions if there are any.
Thank you for your presentations. Any questions? Okay, one question for me. Have you developed any applications for smartphones, or
Uh,
use it or implement it in?
we we due to the narrow timing, we were not able to develop an application. However, we simulated the process in uh, a poor hardware devices that are in the same level as an average or below equivalent in smartphones. And the results are showing in here are simulated in a device that is having a hardware capabilities of an average or below of the the mid-range smartphones, we can say that.
Okay, thank you.
But that's also part of the future plans as well.
Thanks. Thank you for your presentation again. So we can move on to the next one. Mikhailo Zikhalov.
Yeah,
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 are you here?
yes,
I'm
I'm
sorry
here.
if I mispronounce your name.
No worries, no worries. Uh, so you can hear me good?
It's okay.
Great. So let me share my screen. It's supposed to be visible now.
It is visible. You can start.
Great. So, good day, everyone. Today I will be presenting on the topic neural networks as a basis for adaptive smart technologies, theoretical and practical aspects. The rapid growth of data and increasingly complex information environments have created a critical need for adaptive intelligence technologies, particularly in ensuring reliable cybersecurity. Neural networks, with their capacity for retraining, optimization, and processing both temporal and spatial dependencies, are at the heart of this transformation. In this study, we analyzed both theoretical foundations and practical applications for neural networks in forecasting, anomaly detections, and malware classifications. We focused on architectures such as multi-layer perceptrons, recurrent networks, including RNN and LSTM, transformants, and export adaptive learning algorithms, regularization methods, and optimization strategies. Experimental results demonstrate high efficiency, achieving accuracy level up to 95%, confirming that adaptive neural networks provide a robust framework for information security systems. Choosing the right neural network architecture is crucial. It depends on the nature of your data and the task at hand, as well as trade-off between accuracy, training speed, and requirements. Table 1 here summarizes the key characteristics of the main neural network architectures along with their functional limitations. Deep architectures deliver high accuracy and are suitable for large datasets, whereas simpler models are more appropriate with the when the resources are limited. The choice of architecture also informs the design of training algorithms and the implementation of adaptive system properties. Essentially, your architecture shapes not just the model performance, but also its practical usability in real-world scenarios. Adaptability is a key property of neural networks. It ensures model stability and accuracy even in dynamic environments. By formalizing adaptability mathematically, we can predict training effectiveness and select the most suitable algorithm for specific tasks. For example, on the slide here, you can see that Adam algorithm provides rapid adaptation while maintaining high stability, making it ideal for large datasets and applications that require robustness to unstable gradients. To improve generalization and prevent overfitting, regularization techniques like dropout randomly deactivate neuron during training. This reduces the network dependence on specific features. Table 3 presents the effect of different regularization methods on a model accuracy when trained on the same dataset. The efficiency of neural network training also relies heavily on proper data preprocessing, standardization, normalization, and class balancing. Early stopping, based on validation loss monitoring, prevents overfitting and reduces computational costs, enhancing both model stability and accuracy. Early stopping significantly impacts learning rate and accuracy. For anomaly detection tasks, the loss function is typically defined as the root mean square error between actual and predicated traffic characteristics. The use of recurrent network enhances the accuracy of anomaly detections by capturing temporal dependencies. This enables more effective protections against sophisticated network attacks and supports the integration of neural networks into cryptographic security system for automatic threat detection and response. Neural networks can predict vulnerabilities in encryption schemas, reducing the risk of attacks and improving the reliability of informational channels. Beyond cryptography, they are also highly effective in malware detection, classifying files and processes as safe or potentially malicious. Monitoring cryptographic channels and detecting anomalous user behavior are also made possible by neural networks providing comprehensive protection. Multi-layer perceptrons achieved classification accuracy up to 95% for ransomware, highlighting their practical effectiveness in information security systems. The goal of our study was to evaluate adaptive neural networks for forecasting, anomaly detection, and malware classification. We employed MLPs, RNNs, LSTMs, and CNNs using data such as network traffic time series, cryptographic signals, and malware characteristics. Performance was assessed based on classification accuracy, sensitivity, and specificity. LSTM networks, for example, achieved optimal forecasting performance at a learning rate of 0.005. RNNs demonstrates the highest efficiency in anomaly detection, capturing time dependency between traffic packets. Our experiments produced significant findings. LSTMs increased forecast accuracy to 94%, enabling the anticipation of lead peaks and anomalies. RNNs reduced missed unauthorized access attempts by 10%, improving sensitivity and specificity. Multi-layer perceptrons achieved up to 95% classification accuracy, as I mentioned earlier, for ransomware, and 92% for Trojans. The result indicates that adaptive learning algorithms combined with weight regularization significantly enhance model accuracy and stability. The best combinations were LSTM with ADAM for forecasting, RNN with RMS probe for anomaly detection, and MLP with dropout for malware classification. In conclusion, adaptive neural networks provide an integrated framework for performance assessment and comprehensive cybersecurity protection. The study confirms their central role in adaptive intelligent technologies, with the effectiveness of model depending on architecture, learning algorithms, optimization, regularization, and data preprocessing. Practical experiments showed that LSTMS excels in forecasting, RNN and CNN improve anomaly detection, and multi-layer perceptrons achieve high accuracy in malware classification. Overall, adaptive neural networks enable unified prediction, anomaly detection, and threat classification, enhancing accuracy, response speed, and system reliability. These findings provide a foundation for the further development of intelligent data protection system and the integration of AI into industrial and governmental information infrastructures. And that's it from my end. Thank you for your attention.
Thank you for your presentation. Any questions for the study you would like to ask, maybe? Probably not. Thank you again.
Thank you so much.
Now we in the list, Slavena Tihova. Are you here? Not here. And then the Vladimir Hristo. Based on the list,
Hello.
based on the list, you have two back-to-back presentations, probably, right?
Yes, just a moment to share.
Okay. Once you finished one, and then you can move on to another one, okay?
Yes. Uh, and do you, do you
Yeah,
see
it is
me?
visible. We see.
Hello, dear colleagues. I will present with my PhD students a web-based image segmentation tool for education purpose using Java. Uh, This paper presents the development, implementation, and evaluation of web-based image segmentation tool designed specially to support educational activities in computer vision and image processing. Image segmentation is a fundamental component of modern visual analysis. Enabling object extraction, scene understanding, and high-level interpretation of digital imagery. However, many exciting tools require installation of specialized software compatibility with specific libraries and advanced configuration steps that can hinder their adoption in academic environments, particularly among beginner level students. Our motivate by this challenge is the proposed system aims to provide an accessible, platform independent, and pedagogically oriented to student solution that runs entirely in the web browser without additional setup. The application integrates two classical segmentation algorithms. K-means is the first clustering, and GrabCut selection for their complementary characteristics and education values. K-means offers an intuitive color-based segmentation approach ideal for introductory exercises, while GrabCut provides a more sophisticated graph-based method capable of production precious to foreground extraction. The system enables students to upload image, adjust algorithm parameters, visuals output, uh, and compare segmentation results interactivity. This hands-on focus support the development of a deeper conceptual understanding of algorithmic behavior, strength, and limitation. Technically, the platform is built using a modern Java technology stack that backend is developed with Spring Boot, ensure efficient request handling, streamlined dependency management, and a stable execution environment. The leaf is for a dynamic HTML rendering, providing flexible integration of content and enabling responsive user interface updates. For image processing, tasks include GrabCut. I forgot to put them. For image processing tasks, include GrabCut operation, and the system OpenCV accessed through the Java C PPU framework, offering high-performance processing without the need. A multi-stage evaluation was conducted to assess the system accuracy, processing performance, usability, and robustness. Our experiments were performed on a dataset of 50 diverse images, including natural scenes, portraits, medical scans, and artificial diagrams. Accuracy was assessed using intersection over union, pixel accuracy, and F1 score. Results showed that GrabCAD consistently outperforms K-means across all metrics, achieving of 0.78 and F1 score of 0.83 compared. Performance tests indicate that CAM means provided substantially faster processing times, making it suitable for real-time classroom demonstration, while GrabCode require more computation resources due to interactive optimization, but remains with acceptable limits for interactive use. Usability and stability were evaluated through students' trial involving participants with varied technical background because we test with 20 students in web app and stability testing confirmed that the application operates reliably under repeated usage scenarios, and the integrated fallback mechanism to OpenCV functionally. Overall, the developed tool successful bridged the gap between theoretical concept and hands-on experimental in education context. It lowers to entry barrier for learning image segmentation, provides a flexible and scalable platform for teachers and our colleagues. And the students offer the opportunity to explore computer vision technique directly in browser. Our plan to future is enhancement include integration of additional segmentation model, incorporation of external dataset, more advanced interaction features, and real-time to performance optimization. The system represents a strong foundation for building comprehensive and web-based education resource in computer vision and artificial intelligence. This is the first paper who was I presenting. Thank you. If you have any question.
Thank you. Any questions for this study? Okay, no question. You can continue.
Okay. Do you see the second presentation?
No, still the first one.
Just a moment. The second presentation is continued. First, it's a performance analysis of classical machine learning based image segmentation algorithm in a Java web environment. This paper presents an extensive comparative study of classical image segmentation algorithm and modern deep learning based methods to deploy with Java web application in our Java program. The rapid evolution of computer vision technology has expanded the use segmentation across fields such as medical diagnostic, autonomous system, industrial, and so on. However, integrating computer intensive segmentation algorithm into web-based system introduce unique challenge related and study evaluation classical method Cummins and GrabCAD, state-art of deep learning model, deep WAP version 3, and UniNet implementing in Java technologies, including Spring Boot, OpenCV, and Java CC with a deep Java library. What else? In contrast, Deep WAP version 3 and QNet represent modern semantic segmentation paradigms capable of high precision labeling and robust boundary detection of a cost efficient, higher computational independence on GPU acceleration. We tests were conducted on diverse data set, including Pascal VOC 2012 and BSD-S 500 and the medical decathlon library segmentation dataset has a scenery covering simple object, complex scene, and aerial imagery and medical scans. Evaluation metrics include intersection, over union, and the result show that Deep WAP version 3 achieved at highest overall segmentation quality with mean reaching 0.78 and unit medical segmentation task achieving dice coefficient as high as 0.89 on library tumor delineation, conformity suitability. This study provides a practical guidelines for algorithm selection in Java environments, and classical methods are ideal for resource constraint or latency sensitive application, while deep learning approach are preferable for accuracy driven scenarios where GPU acceleration is available. Hybrid strategies dynamically choosing algorithm based on image characteristic and system load. Additional contribution include insight into native library integration in Java-specific optimization techniques for intensive image processing. Overall, this work delivers valuable empirical evidence and practical design. Future work will explore adaptive algorithm selection, model compression, edge deployment strategy, and advanced hybrid segmentation, pipelines integration, classical and deep learning based techniques. Thank you.
Thank you again. Any questions for this study? No, thank you again.
Thank you.
Slavena, are you here? Yes. You can.
Yes, I'm here.
Okay, you can present your study.
Okay. Did you see the presentation?
Yes.
Okay. Good day, everyone. My name is Slavena Tikhova, and I am a teaching assistant at the Veliko Tarnovo University. and my specialization is in computer science. The report I'm going to present to you today focuses on modern technologies for virtual reality in education and training. It has been prepared alongside with Professor Emilian Petkov. The report provides an overview of modern virtual reality technologies and their growing use in both education and professional training. It analyzes how immersive VR environments support interactive learning, realistic simulations, and safe practice of complex tasks. The analysis includes current VR platforms, hardware trends, and real-world examples demonstrating their effectiveness. The purpose of the report is to explore how immersive VR transforms learning applications. It aims to show how VR increases engagement, improves understanding, and enhances skills development. The study also highlights key factors for successful integration of VR into educational environments. Virtual reality has become one of the most innovative technologies entering the fields of education over the past 2 decades. Thanks to rapid advances in hardware and software, learning can now take place through full immersion in computer-generated environments. These environments support learning, problem solving, and interactive exploration that are difficult or impossible to achieve in real life. The COVID pandemic accelerated the need of digital and remote learning solutions. VR VR helps for the lack of physical presence by offering safe and controlled spaces for practice and experimentations. It is now widely used across different disciplines, including medicine, engineering, military training, and general education. As a result, VR is becoming a key driver for modernizing traditional teaching methods. There are 3 main types of VR-based learning. First one, we have immersive learning, which involves full engagement in virtual environments using head-mounted displays. This method allows learners to experience situations firsthand, enhancing memory and understanding. Simulation-based learning is the second one, and it is focused on practicing complex tasks such as surgery, aviation skills, or industrial operations. It removes real-world risks and reduces the need for expensive equipment. Hybrid solution combine VR modules with online platforms, allowing flexible access for students in both physical and remote settings. These models increase motivation, participation, and long-term retention. Together, they support personalized and engaging learning experience. Virtual laboratory platforms such as Labster, zSpace, and Google Expeditions enable students to conduct scientific experiments and field exploration safety. The other one, medical simulators that also VR and fundamental VR allows trainees to practice surgical procedures with high realism. There aren't platforms for aviation such as CAE, which which helps flight operations and technical procedures for professional pilot training. Classroom-oriented tools like Class VR and other support creative lessons, design, and immersive language learning. There are also physics playground and others. These platforms demonstrate significant improvements in engagement in learning outcomes. They also show how VR can enrich both STEAM and humanities education. Schools worldwide are successfully integrating VR into their classroom with measurable results. Virtual reality in education enhances students' engagement by making lessons more interactive and immersive, capturing their interest across subjects. It provides practical, real-world learning experience for practicing communication, in new languages to exploring detailed anatomy, for example, allowing students to gain skills and insights in realistic context. Moreover, VR is highly versatile and adaptable, enabling personalized lessons and teaching methods that can be applied across different cultures, schools, and educational systems. Educational VR systems vary widely is display type, resolution, field of view, and tracking technologies. Devices like HTC Vive Pro 2 and Vive Index offer superior image quality and ultra practice tracking, making them ideal for professional simulations. More affordable models like Oculus Rift S provide uh, performance for general educational use. Mid-range devices such as the HTC Vive Cosmos and Samsung Odyssey Plus balance cost and visual quality. Tracking methods differ between inside-out systems and external lighthouse base station. Weights and comfort also play important roles in classroom settings. School with limited budgets generally benefit most for affordable standalone or mid-range devices. Artificial intelligence enhances VR learning by adaptation context to the learner's place and professional learning style. AI-powered speech and emotions recognitions allows for dynamic interactions and instant feedback. Generative AI can automatically create VR screeners, reducing development times and cost. Intelligence avatar serve as digital instructors, guiding learners through tasks and simulations. Data collecting during during VR sessions can be analyzed to track progress and identify areas for improvement. AI also improves accessibility by providing translations and assistance technologies. Combined with VR, AI creates highly personalized and engaging learning environments. VR significantly increases students' engagement by offering interactive and immersive experience. It provides safe environments for practicing dangerous or complex activities, especially in the fields like medicine and aviation. Throughout delayed 3D models and simulations, abstract concepts become easier to visualize. VR support personalized learning, allowing each student to progress at their own pace. The emotional impact of VR, both short-term and long-term memory. It also helps develop empathy by letting learners view scenarios for different perspectives. Overall, VR transforms the learning process into a more motivating and meaningful experience for the students. Despite its benefits, VR faces several challenges. Cyber sickness may occur during long sessions with poor optimization or low frame rates. Shorter sessions, better hardware, and gradual adaptations help mitigate this issue. High initial cost remains a barrier for many institutions, but affordable standalone develops like MetaQuest 3 and PICO4 reduced expenses. Teachers often require additional training for effectively integrate VR into lessons, providing professional developments and user-friendly teaching platforms is essential. Technical maintenance and device management also pose difficulties, which can be addressed through centralized management system and regular updates. With proper planning, these challenges can be overcome. As VR devices become more affordable, even budget-limited schools can adopt immersive learning tools. The future of education will rely on training teachers and students to use VR effectively. Institutions should create strategies for ethical and purposeful integration of VR in the institutions. Collaboration between schools and technology sectors and government bodies will support wider adoption. Financial and technical assistance will be important for sustainable implementation. Selecting hardware based on educational goals ensures high quality learning experience. Virtual reality unites knowledge and experience, turning learning into an immersive and meaningful process. When integrated with modern teaching methods, VR becomes a powerful tool for skills development and conceptual understanding. Real-world case studies confirm its effectiveness in rising achievement, motivations, and confidence. This position VR as a central component of the future learning for now. Thank you for your time and attention.
Thank you so much. Any questions? I would like to ask you a question about this study. Have you ever implemented these ideas on a small or a school or something like that?
Yes, I'm
an idea
also.
or
Yes, I'm also work as a high school teacher in the field of physics and mathematics and informatics. And I've tried all these ideas before doing this report. I can see by myself the potential of these VR technologies in school because it helps students learning more effectively.
Okay, thank you. Thanks so much.
Thank you.
So the next one is Omar Kouassi. Are you here,
Omar?
Omar?
Yeah,
Okay.
I'm here. Yeah, just give me a moment to share my presentation.
Sure.
Is it clear for you?
Yes, now we can see it.
Yeah. Actually, good afternoon. The paper ID is like 192. This is the title of my paper, which is like LSTM, autoencoder dynamic thresholding and explainable autoencoder for cyber defense. This is the outline of my presentation. I will start with the introduction, give some overview, then give a brief contribution about this paper, then problem statement, then explain the proposed methodology and show the results, and finally the conclusion of this research. This is the introduction. The topic is about the intrusion detection system, which is like considered like very essential for security modern networks, clouds, and industrial systems. However, existing IDS has many challenges. The first challenge is high dimensionality noise features, which is related to the dataset, and the second thing, poor generalization. The third is lack of interpretability. Then finally, we have the static thresholds. The goal of this research is to develop an intelligent intrusion detection framework that improve accuracy, adaptability, and interpretability. The research contribution, we can conclude in 3 points. The first point, here we have the hybrid anomaly detection, which is combined two techniques, which is LSTM and autoencoder. And the second point is adaptive threshold mechanism. And finally, explainable, we have employed explainable artificial intelligence integration. Here we have the proposed methodology workflow. The first step, we have dataset. We have used two dataset, which is CIC-IDS 2017 and also UNSW. Then we have the next step here as shown, pre-processing. In the upcoming slides, I will explain each step in details. So then we have this block for anomaly detection, and here we have explainable artificial intelligence, and here performance matrices and all the details. In this slide, we have the data collection and pre-processing. We have used two dataset. And here we have the pre-processing steps, which is data cleaning, future encoding, missing values, and normalization. And finally, we have sequential windowing. Here we have this block we have for the anomaly detection is divided to two sections, LSTM encoder, LSTM decoder. The main idea of this one, to filtering, okay, or to decide, if this anomaly or abnormal or normal depends on the thresholding. If it is the large data, it means this is abnormal. If it is less than thresholding, it means normal or there is no attack. Here we have in this slide explainable artificial intelligence. Actually, here we have like integrating this explainability layer to make decision results transparent, trustworthy, and also provides global and local to allow the model to make a decision. And also finally, we have an close temporal relevance analysis to explain how futures importance change over the time, which means, here the future when we extracted the explainable helps to which one is more relevant in this in this model, and eliminate which is irrelevant futures. Here we have the results as shown. The proposed methodology achieve in this dataset, UNSW achieved in terms of accuracy 95.6 compared to the baseline method as shown. Then we have the F score also is achieved higher F score performance matrices than baseline methods. Also, same for the precision and for the recall. For the second data set, actually, this model is achieve very good accuracy according to this CIC IDS 2017 is achieved 98.9, also higher than baseline methods. Same for the F score as shown here, and for precision also is higher higher than the baseline methods. Same for the recall. And the conclusion for this research, the proposal framework effectively detects network intrusions by learning the temporal behavior and also dynamically to traffic changes, significantly reducing false alarm, this is very important part. Overall, this framework delivers high accuracy, which is, very important. Also, adaptability and readability, proving the potential for real world cybersecurity and intelligent threat detections. Actually, for future work, we are planning to use GAN, which is generative adversarial learning, or also adversarial training, or maybe we want to apply for another data set, which is for the IoT, for maybe for banking and financial. Also, is very hot topic consider for now days. Thank you very much. If you have any questions, please you can ask.
Thank you for the presentation. So, any questions? I would like to ask what kind of data set was that? Because I was not able to see any image or, whatever it was.
Okay, this is actually very good questions. Actually, these data set, is considered like CSV files, not image. It's collected by Canadian Institute. Okay, they actually, especially for the data set 2017, there's like a center in Canada. Okay, they collected the data set from the network. Okay, during the 1 year. Okay. Then actually it's public, available in Kaggle. Okay, then we employed this research. But I'm planning actually in the future also to collect a data set, a private data set, okay, from a local network. Okay, then we can apply it here also. It will be considered very good novelty. So at the end, and the specific answer for your question, this is CSP, not image at all.
Okay, thank you for your
Thank
answer.
you. Yeah, thank you.
Okay, we can move on to the next one. Roman Korolov. Are you here?
Yes, I'm here.
Okay. You can share your screen.
Yes, just a second. Can you see?
It is visible, yeah, we can continue.
Good day to you all. My name is Roman Korolov, and I will present presentation about article for post-quantum authentication and authorization using the Niederreiter code theoretic scheme. Implementing effective authentication and authorization mechanism is becoming a key element of the security strategy for any modern organization, from small businesses to large corporations and government agencies. Authentication verifies the identity of a user or system, and authorization in turn is responsible for distributing access rights to resources after successful authentication. Together, authentication and authorization provide comprehensive security for information systems, protecting them from unauthorized access and data leaks. The aim of the work is to develop a method of authentication and authorization based on NetRider's code theoretic schemes. The basis of the scheme is the use of correction codes for encryption, which makes it resistant to attacks based on quantum computing. The work proposes usage of NetRider scheme for authentication and authorization of the authorized users. As a basis for the development authentication authorization method, we will take challenge response authentication. Challenge response authentication is schematically shown on the following figure. It contains, for this example, the user and authentication server. Challenge response authentication is contains three main components: challenge initiation, client response, and verification response. One of the variants of the proposed approach of implementation of the challenge response authentication and authorization in wireless channels is the use of two-way communication channels to ensure secure transmission of commands. For example, the connection between a key fob and the onboard car computer. A schematic illustration of this method of challenge response authentication and authorization is shown on the figure below. On the previous figure, there was shown stages, and at first stage, upon request, an information sequence is formed from the output of the pseudo-random number generator and using S blocks and multiplexers. At the second stage, the reverse transformation performed, and according to the known information sequence, an error and weights generated. At the third stage, an error is being generated depending on which button was pressed. At the fourth stage, finding and transmitting the syndrome via the communication channel is performed. The formed syndrome is used for preventing data interception during transmission over an open communication channels. Then it is multiplied by the permutation and diagonal matrices. At the fifth stage, the reverse conversion takes place. An authorized user, knowing the matrices secrets, finds the error vector. If generated errors that was generated at first stage are equal to the errors received from the fifth stage, then the command that corresponds to the error is executed. As a pseudo-random number generator, it is possible to utilize shift registers with linear feedback, which allows forming sequences of the maximum periods and are implemented both in software and hardware. The value of the shift register with linear feedback is divided onto blocks of sizes of m bits. The number of blocks depends on the code correction ability of the algebraic code. And in conclusion, the post-quantum cryptography plays a key role in ensuring the security of authentication and authorization in the future, when quantum computers will be able to threaten existing data protection methods. The development and implementation of post-quantum algorithms will be a necessary step for the long-term protection of information systems. The proposed scheme based on NetRider code theoretic scheme, like other code cryptosystems, i.e. Macauley's cryptosystem, is based on solving the decoding problem, which remains difficult for quantum computers. Unlike cryptographic systems such as RSA or ECC, which can be cracked using Shor's quantum algorithm code-based schemes that are not susceptible to these attacks. Thank you for your attention.
Thank you for your presentation. 2. Any questions? Okay, no question. Thank you again.
Thank you.
So we can continue with Antonio.
Yes, Mohammed, I'm here.
You can share your screen.
All right. Good morning, everyone. And my name is Antonio Cortés Castillo. The title of my presentation is Neural Network Architecture for Enhancing Data Center Intelligence through Deep Learning. Some aspect to be threatened or to be concerned is have two relationships to introduction or objective, the problem, and the factory spine leaf traditional network architecture, generative artificial intelligence with a data center and or proposed model, etc. With respect to introduction, we can see that they have to see in the article, we have begin with analyze of traditional fat-free spine leaf network architecture is optimization and integration of generative artificial intelligence, GenAI, into data centers. Exists a series of a metric that permit to identify a data center label, for example, latency, throughput, packet loss, bandwidth, jitter, error rate, network utilization, uptime, average response time, and others. They are a part of the general metrics that you have called servers, leak performance, and that help us through the analysis of the neural networks. 25 which of these metrics owns normalized, thus are the most relevant for the correct operation of the data centers. To train the architecture model for GNA data center, in addition to using neural networks, we also use linear equations and regression analysis for predictive and residual values, respectively. Between our objective, the first, this objective is analyze the most relevant problems that arise in data centers with the aim of providing practical solutions for efficient and effective management and operation. And the second objective is they select the most critical metrics to be considered in the data center and propose an innovative approach to analyze and experimental which them through neural networks. The third objective is build a model architecture for a data center that can be used to model the select metrics. And the fourth objective is simulate the select metrics using independent variables in such a way that optimized results are obtained that help to solve problems identified in the data center. Basically, the problem is to dive into the complex world of data center management, a problem that company operators struggle to manage due the high demand for data quality and the need to manage high quality customer service. So we apply deep learning with neural network to a set of data related to data centers. The metrics and labeling is with the respective name and numerical value, simulation and conduct using multi-layer perceptron and linear basic function algorithms. This approach helps to obtain normalized results from the independent variables introduced in the partner, demonstrating the need for advanced solutions, specifically in the field of the data center. In this figure, in the in the bottom, we can see the physical components. That's in this case, in this particular case, is the components as switches. Each switches is two relations which servers in the label 0, and the label 0 these relationships with the label 1. Basically, this is the scheme on the factory spine leaf traditional network architecture. The idea is to take this traditional architecture and to incorporate the component, the generative intelligence with the data center. In the scheme, we can see who we take the label computer leaf or label 0 to incorporate the GNA computer leaf with mixed with the shared device. In the table 1, we can see the different type of data center, GNA, hyperscale, enterprise, and versus different metrics. For example, server link performance, types, server connectivity, switch links, switch label, data transfer, average, ICT. In the particular case, we take the server links performance to evaluate this aspect or particular aspect in the data center. This metric derived different submetrics, for example, latency, throughput, packet loss, bandwidth, jitter. Basically, we utilize a series of the submetric derived from the general metrics, server links performance, which we out in table 2. Each of the submetrics is to simulate in the software package to call ESPA's software static of the EVM version 25, where defined each of the submetrics for evaluate. Our proposed model, basically, we have a data set. We take this metric that's incorporated into the data set, and for evaluate to define type of to use in these metrics. Then using different algorithms, for example, neural network, multilayer perceptron, and the other is the neural network radical backseat function, RBIF, and to take the different algorithms and to try to simulate in these simulation tools, EVM, SPS statical version 25. And then the independent variable selections is select to equal to hidden nodes, number of elements per node, dependent variable to train the model. Finally, the analysis of results is behind this simulation tool. Basically, is introduced in between and the definite type of data to be used of the metrics, and the independent variables introduce the model and the neural networks. Basically, different simulation events are carried out to be observed the behavior of independent variables and the relation with the various hidden layers and the number of the hidden units per layer and the dependent variables. In the section results and discussions and the first phase of permutation, the process begins with a thorough comparison between the predicted value and the dependent variables server link performance. This comparison is conducted with a single-handed layer with a throughput increased 2 units in layer until a total 20 units in research. In addition to above, in the linear equation, there is square value of the linear regression analyzed and the percent of variance explained. This is some graphics that show in the figure 4. We can observe how the symmetrics normalize according to the relevance label we have. For this, we have used a linear regression analyze and its corresponding percentage. The second phase of experimentation is to select for compare the residual value versus the predicted value on the dependent variables for server links performance. The results are present in the table 4. The results, the past figure is present in the figure 5A, which can see the predicted value versus residual. Basically, we can indicate it's a great dependence of the residual of the predicted value, which is not adversarial with given the assumption of errors in linear regression. On the other hand, the positive slope of the 0.09 subject of a more pronounced linear relationships between the residuals and the predicted values, indicating that the predicted values increase so the residual. Therefore, adjustment must be made to the model. In conclusion, we have addressed the concurrent situation of data center from a traditional perspective and they incorporate generative artificial intelligence, a subfield of the deep learning. The integration of Gen AI in the data center management can lead to more efficient, more resource allocations, predictive managements, and improvements overall performance. Similarly, we propose a series of metrics that's used in the context of GNIA applied to the data centers. It is worth mentioning that we have to select one of these metrics called server link performance because it is a comprehensive metrics that encapsulate the performance of the entire server link system. The other metrics contains a series of metrics to be assessed and evaluated in a future article. Thank you very much.
Thank
Any
you.
questions?
Thank you. Any questions for this study? We asked. No question. Thank you again.
Thank you, Mohamed.
So based on the list I have, there is no one left, so we can end our session here. So have a good day. Thank you for your attendance.
Thank you, everyone. Thank you.
Thank you. Bye.